Welcome to the DIY Honda Garage channel. DTC P050A refers to a specific issue within the Honda Odyssey models from 2011 to 2017. The error signifies a problem with the cold start idle air control system's performance. This system is essential for managing the engine's idle speed during cold start conditions, ensuring smooth operation even when temperatures are low. A malfunction in this system can lead to increased emissions, poor fuel efficiency, and engine stalling. Key components affected by this code include the throttle body, the mass airflow (MAF) sensor, and the engine coolant temperature (ECT) sensor. Proper diagnosis and repair are crucial for maintaining optimal engine performance and overall vehicle reliability. DTC P050A specifically pertains to the cold start idle air control system's functionality. This system helps maintain the correct amount of air for combustion when the engine is cold. The primary component involved is the throttle body, which regulates airflow into the engine based on the driver's throttle input. The MAF sensor plays a significant role, measuring the amount of air entering the engine to ensure the fuel injection system can provide the appropriate fuel amount. Located typically near the air intake, the ECT sensor monitors the engine temperature, directly affecting the idle air control system's performance. If any of these components fail or show inconsistent readings, the error code P050A may be triggered, leading to operational issues. There are several potential causes for the P050A error code. A blocked or improperly installed intake air duct could obstruct airflow, impacting the engine's ability to receive the necessary air under cold start conditions. A damaged air cleaner housing can cause unfiltered air to enter the intake, leading to contamination and impaired operation. The air cleaner element itself may accumulate dirt or debris over time, restricting airflow and affecting engine performance. Additionally, faulty connections or loose terminals at critical components such as the throttle body, MAF sensor, or powertrain control module (PCM) can disrupt the communication between these systems, thus triggering the DTC. Each of these factors can complicate the vehicle's cold start performance and must be addressed properly. Symptoms of the P050A error code may vary, but commonly include a rough idle when starting the engine in cold conditions. Drivers might experience the engine stalling unexpectedly, especially when coming to a stop. Increased emissions may result from inefficient fuel combustion, as the engine struggles to maintain the appropriate idle speed. A consequent effect of these issues is poor fuel efficiency, leading to higher operational costs. Observing these symptoms can help in recognizing the onset of the P050A error. Immediate diagnostic testing is advised to confirm the presence of the code and prevent potentially severe engine issues. The initial troubleshooting step for diagnosing DTC P050A involves turning the ignition switch to the on position, specifically the II setting. This prepares the onboard diagnostic system to review current statuses and logged codes. At this stage, it's crucial to record all freeze frame data and any relevant snapshot data stored in the system. This information provides context for the conditions that led to the triggering of the DTC. Afterwards, reviewing general troubleshooting information can offer insights into expected behavior and common pitfalls related to this specific error code. These initial steps set the foundation for a systematic approach to resolving the problem. In this second step, utilize the Honda Diagnostic System, HDS, to check for any pending or confirmed diagnostic trouble codes. It is essential to determine if there are any DTCs other than P050A present. The presence of additional codes may indicate other underlying problems that need to be addressed. If any other DTCs are found, proceed to their specific troubleshooting protocols, as they could contribute to the symptoms experienced. If there are no additional codes, you can confidently move on to the next step in troubleshooting. This step is critical to ensure a comprehensive analysis of all fault codes affecting vehicle performance. The next step requires checking the intake air duct's condition to ensure it is neither blocked nor incorrectly installed. A clear path is vital for proper air intake, especially during cold start conditions, where optimal airflow is critical. If you find that the duct is indeed blocked, it must be repaired or replaced to guarantee that air can move freely into the engine. Neglecting to address this issue could lead to continued performance problems and exacerbate the symptoms associated with DTC P050A. If the duct is in good condition, you then proceed with further troubleshooting steps to identify other potential causes. In this step, examine the air cleaner housing closely for any signs of damage. A compromised air cleaner housing might allow unfiltered air to mix with the intake air, potentially introducing contaminants that can harm engine performance. It's crucial to ensure that the housing is structurally sound and permits the proper operation of the air intake system. If any damage is detected, replacing the air cleaner housing becomes necessary to maintain the integrity of the engine's air supply. If the air cleaner housing is in good condition, you will proceed to the next troubleshooting step for a thorough assessment. This step focuses on inspecting the air cleaner element for dirt or debris. A dirty air cleaner element can severely restrict airflow, impacting engine performance, especially during cold starts. It is vital to determine if the element is indeed dirty. If so, the necessary action is to either replace it or clean it thoroughly. Doing this will help restore proper airflow, which is critical for accurate air-fuel mixture regulation. Maintaining a clean air cleaner element is essential for optimal engine operation. If the air cleaner is not dirty, you can continue through the troubleshooting protocol to ensure the system is functioning as intended, allowing the engine to cool until the value of the engine coolant temperature ECT sensor 1 reads 122 degrees Fahrenheit or 50 degrees Celsius or below is the focus of this step. This temperature is significant as it directly affects the behavior of the idle air control system during cold starts. Ensuring that the engine reaches this temperature is crucial for accurate tests and diagnostics. Once the engine is properly cooled, you will be ready to clear the DTC with the HDS and proceed. This cooling process helps to ensure that any tests conducted afterward reflect the true operational state of the vehicle. Inaccurate temperatures could lead to misdiagnosis and ineffective repairs. In this step, the Diagnostic Trouble Code specific to P050A will be cleared using the HDS. Clearing the code resets the engine's control modules and clears all previous snapshots. Once the DTC is cleared, start the engine and let it idle for at least 10 seconds or longer. During this idling period, carefully monitor the onboard diagnostic status for the P050A code. It's essential to observe any changes that might indicate a recurring issue. This step serves to refresh the vehicle's diagnostics and allows for the identification of any persisting problems that could require additional steps or repairs. Following the engine start, the next step is to monitor the onboard diagnostics (OBD) status via the HDS for DTC P050. If the HDS indicates that the status has failed, it signals an ongoing issue requiring further diagnostics. This finding necessitates following the prescribed guidelines for addressing failed tests. If the HDS indicates the status is passed or intermittent, it suggests the system is functioning correctly at that time. Although it's prudent to check terminal connections to ensure there are no underlying connectivity issues. If the system shows executing, you should continue to idle the engine until the system completes its evaluation. An out-of-condition indication should prompt a revisit to the earlier steps to ensure all conditions align correctly. This step involves conducting the ETCS, Electronic Throttle Control System test, within the HDS inspection menu. The purpose is to evaluate the condition of the throttle actuator control valve. The throttle actuator plays a pivotal role in regulating air intake based on engine demands. If the test indicates that the throttle actuator control valve is functioning normally, you can proceed to the next troubleshooting steps. However, if it fails this test, replacing the throttle body is required to resolve the issue. Testing the throttle body is critical as it can directly impact the engine's ability to control idle speed and overall performance effectively. In this step, start the engine and carefully hold the engine speed at 3,000 RPM without load, either in park, P, or neutral. This action must be maintained until the radiator fan activates, indicating that the engine is reaching its operational temperature effectively. Once the radiator fan comes on, allow the engine to return to idle. This step is critical for ensuring that all cooling and airflow conditions are optimal for the engine's functioning. Holding the RPM at a higher level can assist in identifying any issues that may arise under load conditions versus idle conditions. It's a thorough way to assess how the idle control system responds when the engine is under controlled circumstances. The final troubleshooting step requires you to hold the engine speed at 2,500 RPM for approximately 30 seconds. During this time, check the mass airflow sensor data listed in the HDS. A properly functioning MAF sensor should register values between 9.1 and 12.9 grams per second, G per second, at this engine speed. Monitoring these readings is imperative as they provide insight into the air intake process during a steady throttle position. If the MAF sensor's readings fall outside this range, it indicates a potential malfunction or failure. Therefore, it may become necessary to replace the MAF sensor or the integrated intake air temperature IAT sensor, which could contribute to the performance issues under cold start conditions. The final step in resolving DTC P050A involves verifying that all necessary repairs have been completed as per the troubleshooting steps. Conduct a test drive of the vehicle under different conditions to ensure performance is restored and any symptoms previously encountered do not resurface. During or after the test drive, perform a check for any recurring diagnostic trouble codes, DTCs, using the HDS. This final verification ensures the problem has been fully addressed and the vehicle returns to optimal performance without further issues. Documenting these observations is crucial for record-keeping and potential future references. To prevent issues related to DTC P050A in the future, it's essential to conduct regular maintenance of the air intake system and associated components. This includes routinely inspecting and replacing air filters to ensure clean airflow to the engine. Maintaining a clear and properly functioning intake system directly correlates with engine performance during cold starts. Furthermore, monitoring engine temperatures, including coolant temperatures, can help identify any potential problems before they escalate into more serious issues. Preventive maintenance not only extends the lifespan of engine components, but also enhances overall vehicle efficiency, leading to cost savings over time. In conclusion, Understanding DTC P050A and its implications is crucial for maintaining your Honda Odyssey's performance. Following a systematic troubleshooting process ensures that all potential issues are thoroughly examined and addressed, thus preventing further complications. Regular maintenance, including checking air intake components and monitoring engine temperatures, serves to mitigate the risk of encountering this DTC in the future. By being proactive and responsive to the signs of trouble, you can significantly enhance your vehicle's reliability and safeguard its performance. This approach not only ensures a smoother driving experience, but also contributes to cost-efficient vehicle ownership. Please like and subscribe to the channel. See you next time!